Hello, good day. How are you today? You're good, right? Okay, are you ready for today's lesson? You are? That is good. Today in mathematics, we're going to be looking at mean deviation, standard deviation, and variance. All these are in statistics, okay? So today's lesson in mathematics, it's on mean deviation, standard deviation, and variance. Okay, so we're ready for the lesson, right? We are with our books and our pencils or pen to get into today's lesson. Okay, so we're going to be looking at the formulas to solve mean deviation, standard deviation, and variance. Okay, mean deviation is also known as average deviation, okay? Is a measure of the average absolute difference between each data point in a data set and the mean of that data set. Okay, and the formula for mean deviation is the sum of x minus x bar over n. Okay, x represents each data point. X bar is the mean of the data set and n is the number of data points. Do you understand? And next, variance. Variance, it quantifies the dispersion of data points in a data set, okay? And this is the formula, the sum of bracket x minus x bar square over n, okay? Then the formula for standard deviation is the square root of the sum of x minus x bar square over n, or the square root of variance. So we're going to be using this formula to solve some equations, okay? Are we ready? Calculate the mean deviation, variance, and standard deviation of the following sets of numbers: 4, 8, 12, 16, 20, 24, 28, and 32. Now this is a data set. We are to calculate the mean deviation, variance, and standard deviation. So we're going to be using our formulas to calculate this data set, okay? So we're going to be starting with the mean deviation. The formula for the mean deviation is the sum of x minus x bar over n, right? We already have x, which is the data set over here, and now the mean, the x bar is the mean. So to calculate the mean, remember the formula, right? The sum of numbers over n. That is the sum of these numbers over the amount of numbers here. That is 1, 2, 3, 4, 5, 6, 7, 8. There are 8 numbers here. So you add these numbers, divide it by 8. That is what it means. Then we are going to impute our values we have gotten into this formula. So let's go into the solution of finding this. First, you are going to draw a table, okay? And impute your values which you have. The x here represents your data points, and the data points we have are these numbers, okay? These are your data set numbers. So you impute it as the x. Have you done that? Now looking for the mean, you add these numbers. 4 plus 5 plus 12 plus 16 plus 20 plus 24 plus 28 plus 32 is going to give you 144. Did you get that when you added? Now remember, we're looking for the mean, and the mean is the sum of numbers over the amount of number, right? So now we have 144 divided by 8. Remember, it's 8 number we counted before. 1, 2, 3, 4, 5, 6, 7, 8. So 144 divided by 8. When you divide this, what is going to be your answer? 18, right? So now we have gotten our mean. Let's look at our mean deviation formula to see what is next. the sum of x minus x bar over n. This is the mean deviation formula, right? We have gotten our mean, which is the x bar. Now the next step is to get this, okay, the sum of x minus x bar. So what we are going to be doing, this is x that represents each data point, right? So we are going to be minusing each data point minus the mean, which is 18, okay? So you draw another column and start with 4. 4 is the first data point. So 4 minus 18 will give you what? Minus 14, okay? We are solving for this, okay? X minus x bar. The x bar is the mean, and this is the individual data point. So we're going to be solving for each of these data points, okay? So 4 minus 18, which is the mean, is equals to minus 14. Then the next one is 5. Sorry, here should be 5, not 8. So 5 minus 18 is going to give you minus 10. Are you following? Then the next data point, 12. 12 minus 18 is going to give you minus 6. 16 is next. 16 minus 18 is going to give you minus 2. 20 is next. 20 minus 18 is going to give you 2. The next data point, 24. 24 minus 18 is going to give you 6. And the next data point, 28. 28 minus 18 is going to give you 10. And the last data point, 32. 32 minus 18 is going to give you 14. I hope you're not confused with this process. Now that we have gotten this, we are looking for the absolute values, okay? This bar, those straight strokes over here, represent the absolute values. And what does that mean? It means the positive difference, okay? Most of those answers we got here has minus in front of them. So here we are to look for the positive difference, which is every number that has a minus in front of it changes to plus, okay? Do you understand? Because this is what we're working with, the absolute value of x minus x bar. So you draw another column and put the absolute value of x minus x bar, okay? So every value we got from here that has a minus with a negative sign in front of it changes to positive, okay? So minus 14 changes to 14. You don't need to put the plus sign in front to show that it's now positive, okay? Minus 10 changes to 10, minus 6 changes to 6, minus 2 changes to 2, 2 changes to 2 still is still 2, 6 is still 6, 10 is still 10, 14 is still 14. So now we are going to sum this up. Remember, we're looking for the sum of the absolute values of x minus x bar, okay? So we sum this up. 14 plus 10 plus 6 plus 2 plus 2 plus 6 plus 10 plus 14. When you sum this up, what is going to be your answer? The total is 64, okay? When you sum this up, you're going to have 64. So we have gotten our absolute value. So it's 64, okay? The sum of x minus x bar is 64. Over the number, remember the number is 8, right? 1, 2, 3, 4, 5, 6, 7, 8. So over 8. 64 divided by 8 is going to give you 8.5. Okay? Did you get that when you divided? 64 divided by 8 is going to give you 8.5. So this is our main deviation, okay? 8.5. Do you understand? Now we have gotten the mean deviation. We are going to be looking at how to solve the variance. Remember, our formula for solving the variance is the sum of x minus x bar, bracket close, raised to power 2 over n. So now we are going to be solving for x minus x bar raised to power 2, okay? Remember, we have already gotten the values of this, right? X minus x bar, which is here. So now we are just going to square each of these differences, okay? So you draw a column, and on top you write x minus x bar raised to power 2, okay? So each of those values we have gotten here, we are just going to square them, okay? So minus 14 raised to power 2 is going to give you what? Minus 14 times minus 14. That is what we mean, okay? Minus 14 times minus 14 is going to give you 196. It is not minus 14 times 2, no. Minus 14 times minus 14, 196. The next, which is 10, so it's minus 10 raised to power 2, it's going to give you 100, right? Minus 6 raised to power 2 is going to give you 36. 6 times 6, not 6 times 2, okay? 6 times 6 is 36. Next, minus 2 raised to power 2 is going to give you 4. Next, 2 raised to power 2 is going to give you 4. 6 raised to power 2 is going to give you 36. 10 raised to power 2 is going to give you 100. And 14 raised to power 2 is going to give you 196. So now we have gotten the square of x minus x bar, right? So now we have to get the sum. Remember, this sign is the sum, okay? So we're going to get the sum of all these numbers we have gotten as our answer, okay? We're going to add 196 plus 100 plus 36 plus 4 plus 4 plus 36 plus 100 and plus 196. When you add all this together, what did you get? 672, right? So the sum of x minus x bar raised to power 2 is 672 over the number. Remember the number 1, 2, 3, 4, 5, 6, 7, 8, right? Over 8. So 672 divided by 8 is going to give us what? You can use your calculator or the long division method, whichever one you want to use. 672 divided by 8 is going to give us 84. So we have gotten our variance, okay? Our variance is 84. Do you understand? Good. So we have solved for the main deviation, which we got 8.5. We have also solved for variance, which we got 84. Now we are going to be solving for standard deviation, okay? The formula for standard deviation is the square root of the sum of x minus x bar raised to power 2 over n, or square root of variance, right? Do you know what we mean by that? You know, this we have here is the formula for variance, okay? The sum of x minus x bar over n, right? This is the formula for variance. It's just squared. So the standard deviation is the square root of the variance. But we're going to be using this long process still. The next one, what I'm going to show you. Okay, so the square root of 672 over 8. Remember this value which we got here, the sum is 672. So over 8, the number, you can see is still the same as the variance, right? So 672 over 8 is 84, right? So the square root of 84 is what? If you calculate the square root of 84, it's going to give you 9.165, okay? 9.165. So our answer for standard deviation is 9.165, okay? Do you understand? So we have gotten our mean deviation, which is 8.5, and our variance, which is 84, then the standard deviation, 9.165, okay? We are to calculate the mean deviation, standard deviation, and variance, right? So we have gotten our answer. Did we understand this example? So let's look at another example to help us understand better.